us this week, the Eigenbros, JJ.
Yes, indeed. Terrence.
A.K.A.
Black Aristotle, apparently.
Yeah, there you go, man. We just kind of want to give you a little overview of what we talked about this week.
So basically, we talked about machine learning. So we went over the FaceApp and the age challenge.
Yeah.
So it kind of blew up on Twitter. And then we also talked about some of the problems of machine learning and also the future of machine learning.
Yeah.
So, you'll see that this episode. And thanks for tuning in.
Yeah. And also, don't forget to check out our social media.
Yes, we have Twitter is at Eigenbros. Make sure to subscribe to our channel, like and comment as well. And we're going to be pretty much on any of the major media platforms for audio. So if you want to listen to the podcast, just go to Apple, Spotify, Google Play, whatever the heck you want.
True. And if you're on iTunes, please leave us a review if you really like us. If you don't like us, don't leave a review. Don't be that.
Don't put anything.
Yeah, don't be. Yeah. Don't be that person on doing reviews on like Yelp or something, just being mad. This is not the place.
No, actually, any reviews are good. Just leave us feedback.
Okay,
we like it all.
Yeah, feedback actually is good. That's not a review. So please feel free to do that. So anyways, thanks guys. And we go into the show. 3, 2, 1, and we're live once again. The Eigenbros.
Indeed.
So, man, you did a lot of work this week.
Yeah.
Yeah, you got
a lot of
outreach.
Sitting on Twitter.
Yeah, a lot of outreach, right?
Yeah.
So we got noticed by Senpai.
We did. The great Eric Weinstein.
Yeah. He gave us a shout out.
Well, he gave us a little reply.
Nah, he did. A shout out, it's the same.
Yeah.
No, I'm just kidding.
We're so lame.
So how do you feel now that you're famous?
Dude, it's good. I'm glad something's working.
Yeah, for sure. Oh, hold up. Let me lower you down a little bit. Ooh.
Oh, on your microphone, on your headphones?
I got you blasting, bro.
Oh, on yours?
On you.
On me?
Yeah.
I'm fine. It's not that bad.
There you go.
Okay.
You're good. All right.
It was fine though.
No, it was this one. It's because we plugged it. Whatever. We just
okay. Oh,
technical
the wrong
issues.
thing.
Yeah,
Okay.
I had it plugged in on the wrong one. But
I see.
Rest in peace, headphone users. In the first
people?
2 minutes. Yeah.
Oh fuck! We should just redo it, Juan. Let's just redo it.
Nah. This is. Come on, you're watching how the sausage is made.
We can't be having the sausage made every time.
Come on, this is comedy.
God damn it.
This is comedy and science. You don't get a lot of mixture of both nowadays.
That's a good way to bullshit around.
Come on, man.
Technical shitty.
I like to
shitty
think that I'm
difficulties.
I like to think that you're a funny guy. I like to think that I'm a funny guy.
Debatable.
Yeah, true. Speaking of fun things this week.
Yeah.
FaceApp. What is it? The FaceApp.
Yeah. FaceApp. Yeah. So they kind of exploded on Twitter and probably elsewhere too. Maybe Instagram. I'm not really good with Instagram.
Yeah, the whole world was age swapping. They were.
No, they were. I don't know if you call it age swapping. It's more like or aging themselves or unaging themselves, and then they're gender swapping.
Yeah, but it was like you can get discounts now at like when you go buy tickets, in the movie theaters, like through the app. Just say veteran. What is it? Senior discount?
Senior discount. Or child ticket.
Yeah, or child ticket. There you go.
Yeah, man. I used to get child tickets for like a good 4 years when I was going to the movie theater still.
Still? Do you still do that today? Do you still do that today?
No, I don't do today. Because when I was in high school, you know how you are as a broke high schooler.
Yeah.
Basically, they had these little kiosks in the mall where you could just use your credit card to sign up.
Right.
And you can buy child tickets, adult tickets, or whatever.
Yeah.
And for some reason, you could buy R-rated movies with child tickets.
Huh.
And I was like, okay. And I fucking got child tickets every time, and it was like $6 compared to like $14.
Nice.
So that hack's probably done though now, I'm sure.
I know. Well, the thing is, people still do it because, come on, who really cares?
Yeah.
Like people working at
I'm
the
just saying, I don't know if they
thing.
can now, because I'm sure somebody probably had to catch that by now.
Yeah, I mean, it just depends. Like if there's a teenager working at the ticket check thing, he's just gonna scan your ticket and be like, "Yeah, there's like it's gonna be to your left when you walk in," that kind of thing. You know, it's still possible.
I'm saying I don't even know if the programmers might have changed the kiosk to where you can't get movies with a child ticket without an ID or something.
Oh,
you see what I mean?
Nah,
or you can't get child tickets alone.
The thing is, you can do that online now. You can just buy your tickets like.
You can get a child ticket?
Yeah.
Oh,
Seeing
there you
your
go. So
child.
it continues.
Yeah. Is it a crime to save money nowadays? Huh?
Tell it to the judge.
Can you really go to jail for that kind of thing? I wonder.
If you could, that would be a sad world. It's like some North Korean bullshit right there.
It really is. So like the social credit thing. Did you hear about that?
Oh, in China?
Yeah. They're developing instead of like, financial credit, they're building social credit.
Sounds like a Black Mirror episode. I'm pretty sure there was one that had that.
Dude, how do you think America would not work?
Nobody would give a fuck.
The thing is,
they would just throw it. I would not give a fuck.
No, but the social credit thing, right? It's built so that you basically get put in. I think, do you get prison time if your credit gets below a certain?
I did not research into it at all.
Because I'm going off the top of my head.
Chinese system.
Let's just say they do go to prison.
Okay. It's probably wildly incorrect. So don't listen to anything we're saying right now.
Yeah, this is just off the cuff.
Yeah.
Just dialogue, man. Just, this is like old school, man. Just what I'm trying to think, like what is the point of something like this? What do you why would you as a nation adopt such a policy?
It makes sense, I guess, right? You can see the immediate benefit from it because you can keep people acting right,
Yeah, but that wouldn't work here because we're already assholes and no amount of social credit.
Well, if it affects you in some kind of, real way.
I imagine it affects your job prospects.
Sure, that'd be a big incentive for people to actually adopt the system.
It's like here where your social security number follows you. This is like your social credit number follows you.
That would suck so much.
That does suck.
I would just opt out.
Yeah, because every bad thing, right, is cataloged.
Yeah.
I wonder if you start at like 700 points. Do you start at a perfect score and then go down from there? Or?
Yeah, I don't know. Whatever it is, it sounds like a very shit system. We already have enough of that these days.
We do.
Yeah, no. So it's already like more shit is just like, I'm done.
But isn't that true freedom, though? True freedom is being able to not give a shit.
Yeah, exactly.
Yeah.
But we still have to give a shit about some things, because we do have credit scores. We do have tests. We do have fucking letters of recommendation. We do have all this junk and garbage that we have to always fulfill. So we already pretty much have a social credit system.
Yeah.
Only it's not a
it's not as oppressive as a number, right?
Yeah.
Yeah.
It's not as bad as it could be.
Yeah. Yeah, I wonder, speaking of other things, going back to, I guess, the FaceApp thing.
Yeah. That's kind of what we wanted to talk about.
Yeah,
so, there's some interesting things going on with that app. So you can change your age, you can change your gender.
Yeah.
It's kind of cool because they actually use these kind of neural networks to do that. So I don't know how much research you were able to do on it, Juan, but
let me try to fill in the holes here. Neural network.
Yeah.
So it's for the uninitiated like me.
Okay.
Let me try to guess what it is.
Sure.
It's a network of computers.
Okay.
Serving as a singular brain.
Okay.
And then once they're connected, they become a brain.
That sounds like something almost.
No, I'm just kidding. That's like super sci-fi. But
it sounds like you almost are describing like a computer cluster.
Yeah, but see, that's what you would think when you think neural network.
Yeah.
At least that's what I would think.
Yeah.
Yeah. But in this case, it's not. It's more like a...
Right. In this case, you can basically run it on a single machine if you wanted to, right? You could run it on multiple units if you'd like. But basically, a neural network is just a system where you have layers. So they call them layers. Pretty easy to know. You kind of see this general image with nodes. I'll put it in the podcast, hopefully, if I remember. But they have these nodes. Every layer has a certain number of nodes. And then those nodes each have something that they do. So it's like if you were recognizing, let's say, and actually, let's get more specific. So we actually know what kind of neural network the FaceApp uses. The FaceApp uses something called a convolution neural network. And basically that just means that it has a convolving process in one of those layers. So if you imagine your neural network, right? Let's imagine you have 10 nodes.
But a convolution, just so people recognize...
Well, I'm going to get to that.
Oh, you're gonna define it?
Yeah.
Okay.
So the neural network, let's say we have 10 nodes on the first layer. Then we have like 9 on the next layer.
Okay, wait. What are nodes?
So nodes are just basically like, you can think of it as they take in some data.
Okay.
So your nodes can take in some kind of data, basically. And the whole thing with the convolution neural network is that one of those nodes that takes in data, they actually have filters on them. So a convolution basically is just a mathematical operation.
It's like a function. It takes the input.
And it's more of like an operator.
Okay.
Rather than a function, I'd say.
Okay.
So I guess it's a function because you can put some information in and you spit some information out, right?
Right.
Yeah, so I guess you can think of it either way. Because functions perform operations.
Yeah.
But so basically you take in some information and it does some process on it, transforming that data, and then you get something out of it. Now, what that would be an example of, let's say you take in like a picture, an image.
Yeah, Instagram does this, even as base level, right? You apply filters to certain things. I imagine that's a mapping of sorts.
Probably. Yeah. I don't really know how Instagram works because I've never actually tried any of the filters, but I'm sure there's probably some kind of thing like that involved.
Like layer 1 is like you change the color of an image. That would be like one convolution or something.
Sure.
Right?
Probably. Yeah. I won't say for sure because I don't know.
Let's just say base terms for like... for a dummy like me, like, where you're trying to figure out what the hell is a neural network. It's like, okay, maybe at the baseline, you can maybe sort of imagine it this way, would you say? Like, it's like you're applying a filter or doing something to an image. Like in this case, Instagram, you can put like a certain color filter on your image.
Sure.
And that's like a very basic, you're changing something in your image. At the baseline.
Yeah, so you're performing something on an image to change it in some way.
Yeah.
But with neural networks specifically, they'll be usually they'll be doing some kind of intelligent transformation. So it's to get some kind of information out of it.
Okay, so they'll look at the image, and in the sense they'll actually process the image.
Yeah, okay.
And correct me if I'm wrong, they actually process the image and see the image, right?
Who sees it?
Like the neural network in this case?
I mean, it doesn't need to see the image because the neural network can just do it with mathematical operations.
Oh, cool.
So it doesn't need to re-render the image. The only way you'd have to re-render the image is if you wanted to see it like the user. The neural network literally uses a mathematical operation, takes data from the image, and then let's say there's something called edge detection. So let's say if you have an image with some borders in it, like a human face, let's say for an example, the neural network will find the edges of the human face. So we'll actually find what edges are in that image. So you can see, okay, these are the edges of the human face. That's what one of the nodes in the convolution layer of the neural network can do, for example. And there's different edges it can find. It can find different kinds of edges, and you can do other things with it, like finding, let's say if you wanted to find like certain patterns, you can find circles in the image, whatever you want to do. Yeah. So it's a very generalized thing that you can do, but for specifically for visual stuff, they want to do it so that you can find things that indicate a human face. And then you can go in layers deeper. So the convolution layer usually is not just a single layer. It's usually you can have multiple layers. And usually the deeper that you go, you get more complex operations. So you can figure out like what's a nose, for example, or what's eyes in the image, or what's a lips in the image. So it can do these mathematical operations to figure that out. And it can do that by doing deeper and deeper things. You know, like for instance, you can say like, oh, you can compare a bunch of pictures of lips in a database of lips and then say, okay, these are probably lips based on the images that we have here because they match with a 90% certainty that is a lip.
Right.
So yeah, these things are pretty interesting and really advanced.
Yeah.
And that is basically how the FaceApp works. It
So
uses that kind of process.
Right. It looks at your face. It does a lot of math.
Yeah.
And then it says, it compares. A lot of the time these things compare with something. Right.
Yeah,
so
exactly.
they'll say, oh yeah, these are eyes.
Yeah.
You know, oh, this shape that I see here is the shape of an eye.
Yeah. So basically, yeah. So it's like they actually have databases. So this is one thing I was interested in finding out. I was like, do the networks generate the actual faces like from scratch? And I was like, how the heck does it do that and like improve it?
Yeah.
But they don't actually. So the thing is, you have a database of faces.
Uh-huh.
And what it does is, we're good?
Yeah, no, keep
Okay.
going. I was like,
Okay,
keep going.
so
I was
what it
just
does
saying.
is basically that database has like, let's say 10,000 faces.
Yeah.
That means it has 10,000 faces that it can use to compare things to, and it can manipulate. So it can manipulate those faces and it can compare those faces. So let's say with FaceApp, what happens is like if you take your picture from like the side, it will look at all of those images that it has that it's already it can match those images to side angle pictures and images, and then take bits and pieces from those images and composite them or take things from them that it can use to generate a new face or something.
Yeah, it's pretty amazing. If you haven't seen it yet, it's pretty amazing in action because it's probably the most accurate mapping of like trying to put age or demonstrate age on a person's face.
Right.
I knew this was something different than just putting wrinkles on overlay, a wrinkled overlay on your face.
They do, but it's not like that simple, right?
Right.
They take images of real people and use their wrinkles and things, I think.
Exactly. Yeah. It maps it in all the right places.
Right.
And sometimes you can change the angle and it'll still map it on the places that would make sense to be on a human face.
Right.
Yeah. It even adds wrinkles under your eyes and shit. It's pretty brilliant.
It's interesting because they do also. So I think this app is kind of an advanced one compared to the other ones.
Yeah.
Of course, it's proprietary, so they don't like to tell their information. So it's kind of like we're guessing at it. But I've read a few articles on it, and they tell some of the tricks they use. So like with some interesting things that people have noticed is that when you do the age app, usually to signal to make it more obvious that someone's aged, there's less contrast between features and like skin tone. So features would be like eyes, nose, lips.
Right.
There's less of a color contrast in aging.
Yeah.
So like this actually is really enlightening to like show you some of the things you may not even think about.
Yeah.
How it changes your look and just understanding like what makes people look old.
Yeah, because computers can recognize that your life is sucked out of you as you get older. It's that lack of contrast.
Right.
The more joy in your eyes. So
And the younger you are, the more contrast you have between your features and then your
that's
skin
silly.
tone.
I didn't know that.
Yeah, I didn't know that either. And then of course there's other more obvious things like with children you have bigger features. So you have like
Anime
bigger
eyes.
Yeah, you'll have like bigger eyes and smaller nose maybe.
Right.
But in proportion to your face, your features will be bigger.
I don't think I tried the youth filter. It's not as great.
Not as good.
No.
Yeah, I think it's a little harder.
The one, honestly, I think the more popular one is the age one.
Yeah.
But that one is brilliantly done. It's so well crafted and it still boggles the mind. It's how accurate it looks.
Right.
I will say the accuracy is, it almost, I almost feel like that is how I'm going to look, because I look like my father does now.
Right.
And the computer doesn't know that. The AI doesn't know that.
Mm-hmm.
You know, it just kind of says, oh, this is how this person's face would probably look if they were older. That's the computer's guess.
Yeah.
And
I think it makes sense too, because the thing is, it's pulling from a data set of like probably like hundreds of thousands of faces, or maybe even more.
Yeah.
And it, you know, like I'd imagine, although I can't really say, there's only a certain handful of faces you can make, right? I mean, the variety is humongous. I'm sure it's like,
but historically,
on the order of
speaking,
exponential. But
have you seen those? Have you seen those things, those memes that people make of like Keanu Reeves has lived 100 years?
Yeah.
Because people, like, you can go back and see some guy that looks almost exactly like Keanu Reeves.
Yeah.
Yeah. It's like, I truly believe that people, you know, you have a limited palette of attractive faces, or faces that are evolutionarily like, how do you
I don't want to
say
say attractive, just you have a limited range of faces probably. I mean, there's a humongous range, but at the same time, like, if you have enough data, you're going to have enough faces to choose from.
But at the same time, you're working with evolution, right? You're saying which faces actually give me the highest chance of having babies.
That's true.
Because
I think it's adding in an extra element that's maybe not necessary.
No, but I'm saying evolution's going to dig in that bag and say, all right, this one worked last time. Let me use this one this time.
Okay.
That's my belief.
Yeah.
I could be wrong. If you're a geneticist or something, you know, correct me.
Well, it just sounds like you're saying like your phenotype gets passed on.
Which, I believe so.
It's true.
Yeah.
Yeah.
I should be right.
I don't think that's controversial.
Okay, good. No, because I feel like I'm getting a little pushback here. You're like, oh,
no.
Oh, okay.
I just think it's not really relevant to what I was saying, but it's okay.
I mean, okay. Fair point. That's a fair point. You can complicate things. You're saying I don't have to complicate.
Yeah.
Okay.
So I think it's just you have a wide range of faces to choose from, and the whole machine learning algorithm, I guess, has a lot of selection. I think it needs a lot of different angles.
Yeah.
You know, that helps a lot too.
Yeah.
But I mean, the app is really interesting. There's also, I was trying to think of some ways that maybe the app can synergize with other things, because I don't know if you've seen the Verge article back in the day where they showed how they can generate human faces that don't even exist.
Yes, I've seen that. Yeah.
So it was a cool, popular one that kind of exploded a little bit back in, I think it was like 2017. Don't quote me if that's incorrect, but I think it was 2017, where there was this group. I
think the guy's name was Ian Goodfellow, who wrote the paper on it.
I forget who he worked for. It might have been NVIDIA or something, like an actual company. But he, they basically, the group created a machine learning algorithm that allowed you to create
faces, really realistic looking faces,
and generate faces from just some large data set of real looking people. And the thing is, that neural network they use is a different kind than what FaceApp uses. So their neural network was actually called a generative adversarial network. And the way that works is, imagine you have two computers, right? One computer has a data set that it generates new faces constantly from that data set. So it randomizes some values and makes a new face every now and then. The second computer is the adversarial network. The adversarial network looks at the faces that the generative network makes, and then it says either yes or no, this is a real image or not. So it says yes, it's a real image, and then that image moves on to the next level. It says no, it's not a real image, and if it's right or wrong, if it's right and it's not a real image, then that is taken, and then that input is given to the generative network. And over time, that generative network, since it's in like a feedback loop, these two computers, eventually the generative network starts producing some really, really high quality, realistic looking images just based on the adversarial network either approving that it's real or not. And eventually it should converge to where the adversarial network just cannot really tell if it's a real or fake image. It should have like a 50% chance of getting either way.
Okay.
I think, because it's so good now that the adversarial network doesn't know if it's a real image or if it's from the data set or if it's a fake image.
So
Dang.
that I thought could be used in conjunction with the FaceApp, because then you could actually be producing more data set in real time. Like if you just set up like a computer where you could just have that adversarial network and you can just be generating faces, then you can feed that into the FaceApp, and then it has more and more and more and more data of just like tons of faces to choose from and different angles and everything.
Yeah. Huh.
And it's really trippy, actually, how the generative adversarial network that's used for the generating faces is, because you can actually combine features from real people, from like two different people. So like they have a nice little image graphic in the Verge article of where you have one axis. So let's say you have a column with a bunch of faces, and then you have a row with a bunch of other faces. You can combine those two columns to make a unique person. And it really is interesting because you can see the features from both people in that one image. And maybe I can even put a picture of that in the actual podcast. It's really impressive looking.
Yeah, I mean, the whole thing is the whole thing is impressive.
Yeah.
But how does this relate to deepfakes? Do you know about deepfakes?
Yeah, I do. I don't know if I know much, but
deepfakes. So that's the one where you basically you do video.
Yeah.
Right.
So you map it onto someone else's face, and
that's a little harder. So with deepfakes, from my understanding, it's very similar. So they take a bunch of images from, but then again, deepfakes is probably is a little bit interesting. It's not something I looked into, so I don't want to guesstimate too much. But I know that they do take in a data set from, let's say, like if you have one person, so you want to make a deepfake of George Bush. You take a bunch of images of George Bush in as many different angles and speaking and things as much as you can. Like if you pull a video of him, that's like great, because then you can get frame by frame every single image of him and just put that into the deep fake, deep fryer, whatever it is, that's generating that those images. And then once you do that, it maps the face of George Bush in that particular expression. So let's say you want to map George Bush's face onto The Rock's face.
Yeah.
You look at The Rock's face and the angle and the shape of his face and how his facial expression is, and you take an image from George Bush's catalog, and then you put that on top. You superimpose that on top of The Rock's face, and then if it's seamless enough in every single frame, it should be a nice little superposition of The Rock and George Bush combined. Although I'm not really sure on the details how it's done, I think that's kind of the general idea behind the deep fakes.
Yeah, because I would imagine it's like you sort of pin the person's face on there, and then the what do you call it? Not the AI, the
algorithm?
neural network, or the algorithm does the computation and the processing of like, how is this face supposed to look when it turns like this? How is this face supposed to look when it moves up? Or, that kind of thing. Yeah, it's fascinating, and it's only going to get better.
Yeah,
which is huge. Like the one I can think of off the top of my head is the one where Obama is like, it kind of is a meme, but where he gets off stage and he drops the mic and then he goes and like kicks the door in or something. Have you seen that? Yeah. But that's
I think
like
you're conflating two memes though. So I think there's one where he just
there's one that he just
kicks the
mic?
door, and then I think there's a real video of him actually dropping the mic.
Oh, really? Okay,
Yeah.
shit. Then maybe I am combined too. Well, yeah. It's but the one where he's kicking in the door, I know that one's fake.
Yeah.
But yeah,
I don't know if that's done with deepfakes though. I think that was actually
Before the technology.
I wonder if somebody used that as a proto thing, but I'm sure, I don't know. But that was really well done. Like you can sort of, it looks real.
Yeah.
And
But that was like different kind of movie magic.
okay.
Because I mean, we've had special effects forever,
Yeah.
So
Oh,
there's
so
other
you're
ways
saying
to
that
do
falls
things.
into the special
I think
effect
it
category.
does. I think
Okay,
it does. Because I remember seeing that way before even anything with deepfakes was
Or
involved.
neural network stuff,
Yeah.
right? Yeah.
Like deepfakes is still relatively new within like the past few years, and that Obama kicking the door in was like, that was like around during the beginning of his career.
Yeah.
Yeah.
It's definitely fascinating. I think there are talks about where this kind of technology will go, because you can get into really scary places like propaganda, and you can get into you can get into, like, people have been speaking on like things like, you know, proposing laws where we ban certain things. Mm-hmm. I don't think we should go that far. Well, what is your take?
On what, banning?
Like banning this kind of technology.
I think that's always it's not going to happen, right?
Do you think it's a knee-jerk response kind of thing?
Yeah, it is. Because, like, you can't ban technology. Well, you can ban technology, but, like, people are going to continue to develop technology. Mm-hmm. The only way it's going to be banned if it's like something that's so catastrophic, it could be, you know, it could end lives.
Yeah.
And deepfakes aren't going to be ending lives. They're just going to be ending careers, maybe. But there will be regulation, of course. Every technology needs regulation at some point. But this is usually a reactionary thing, right? You only know how to regulate something once you have it kind of in the ether or in the system. Mm-hmm. You know, once it's actually baking in the system, then you actually know how to regulate it better. Like, we're still trying to figure out how to fucking regulate the internet. You know, so it's like these things take time. Mm-hmm. Yeah. And I think we're just going to let it happen and let, you know.
Okay.
Damn, she had you good there, man.
Yeah. No, yeah. It's
we're going to let it happen, and then, you know, whatever happens, happens. And then, of course, if something crazy happens, you know, then they'll regulate.
Yeah.
I mean, what do you think?
I mean, I don't think it'll go away. I think it's something that could be useful, right? We don't know the amount of, like, joy it could bring us, because we could necessarily, well, how do I say this? We could recreate things from the past just based off of images. Have you seen, I imagine you've seen this one recreation of Mona Lisa. The AI takes the face and kind of, like, you know, messes around with it a little bit, which is really cool to see.
Yeah. So it takes images from some database of someone who has a collection of images.
Yeah.
And then they map it to Mona Lisa's face, and then it gives her movement.
Yeah,
which is it's really interesting cool. Because that one, it works in similar ways, and you can see though that it pulls from like a certain person, because depending on whose face gets mapped to Mona Lisa, she takes on traits of that
shared
person.
Features, right?
Yeah. So you can have like different versions of it.
It's like a stunt double where, like, you know, you kind of, you get the person who looks closest to that, and then you kind of just work around that.
Right.
Yeah,
because it's working off of one singular image.
Yeah.
So it has to interpolate a lot. And interpolation just means like it has to fill in the gaps, so to say. Yeah. If you're working with one image,
extrapolate in a way.
Yeah, exactly.
So yeah, I think it's stuff like that could come of it. Also, things like bringing history, like other history, like, you know, recreating certain images or certain times in history would be really cool to look at.
Like what? Know? Like whole scenes?
Like
a battle or something, you mean?
Yeah, but like really well done. Like I don't know, maybe the assassination of you know, Abraham Lincoln or something. Yeah.
Dude, actually, you kind of made me think of a really badass video I saw with Peter Jackson. So Peter Jackson was given the task by like some national archive. Right? Yeah, he's the guy who invented Lord of the Rings. I mean, who directed Lord of the Rings? Sorry, that's a very That's if a Lord of the Rings nerd caught me saying that, that's like death.
It's gonna sound off on the comments.
Yeah, definitely not. He did not invent the Lord of the Rings. That was Tolkien.
Yeah.
My phone just dropped. But so Peter Jackson is the guy who made the movies for the Lord of the Rings.
Yeah.
And he was tasked by a specific museum or something, or maybe the National Archives or somewhere, to recreate. You're gonna blast her. To recreate or to utilize World War I footage in a new, interesting way.
Okay.
So he took a bunch of the World War I footage.
Yeah.
And he colorized it. But then he's like, that's not good enough. He's like, let's actually use machine learning algorithms to make the frame rates match more smoothly and to interpolate more frames and things that are missing.
Oh, wow. Cool.
And he added in sound. Like he just did it. He did it fucking up, man.
Wow.
He like went to the next level on it, and he restored the footage of this World War I footage where it looks like it's like a modern movie almost.
That's so cool.
It's like so well done. You're just like, holy shit! Like it gives you a whole new perspective because it actually puts you there now in a way where you can understand it because in our lives we're so used to seeing things Well, the better it looks more like real life.
Yeah.
It's this weird
you don't
disconnect.
feel as removed. Yeah.
You feel like a removal when you look at old footage because you're like, oh, they're just old timey people, and you almost feel like life back then was black and white. So it gives you a weird very disconnected viewpoint.
Yeah.
So this footage that he does when he restores it, it makes you feel like you understand what it would be like to be there.
Yeah.
Like it was the first time ever seeing like war footage like that of World War I where I felt like, oh, I kind of like get it now. Like I get why it was so bad.
Yeah.
Because you can just like imagine the conditions they were in, just like sleeping in shit and blood and, and having to they couldn't take any showers, dealing with bugs fucking all the time and rats fucking eating at your feet and shit.
Jesus.
And it's just like, you really get the sense of being there and like hearing like fucking bombs dropping all day and all night. Like, and it's just like, it's crazy, man. You can like see like the real expressions on these guys in such a better detail.
Damn.
And it was just, like I would recommend it. I wish I remember what
cool.
the name was. It's like
Peter Jackson, what'd you say?
Yeah, World War I, I believe.
Okay.
Yeah.
Wow.
Yeah, dude.
Check it out.
It was a great use
that's
of
where
footage.
the technology. Yeah, but that's what I'm saying. Like cool things like this, where we wouldn't have we can look forward to stuff like that. I guess with some of this tech, like it's kind of scary. There's some people, like I was saying, talking about how this is like huge for propaganda and stuff, and this could be potentially dangerous in the age of information. But I think there's still some positives to, like, as artists, people can do really cool things with it. So, yeah.
But also with this technology that develops, like, so let's say with propaganda, and we do already know of like generative adversarial networks. If you can make some kind of network that can detect very well what is fake and what's not, then maybe you can have some more. You have different methods to test if something's fake or not.
So it's like how people can tell Photoshop is real.
Yeah.
What's Photoshopped and what isn't?
Yeah. So maybe there's some kind of signatures or artifacts that get left behind.
Yeah.
That can tell fake images.
Yeah.
But we're just not there yet. Nobody really knows the full extent of what's going to happen.
Yeah. I mean, do you think there's a neural network that can know the signature of a neural network?
Well, that's kind of where the adversarial networks come in.
That's what that does.
Yeah, at least for visual.
I thought it may be compared. Maybe I have a different idea of what it does, but yeah, that's cool.
Yeah, I'm not entirely sure on how to explain the adversarial network because I didn't look into it so hard. I didn't read any research papers on it. No. But yeah, there's got to be some signatures for it to be able to tell.
Yeah.
Yeah. I'm sure over time they'll find some clever shit. You know how it goes. When something's been in science for a long time, people start to find more and more clever ways of doing things and figuring things out. So
I just wonder if AI can be clever enough to cover its track, or the neural network can be clever
probably.
Enough
So
to
it's probably
cover its
one of these things where it's a cat and mouse game.
Yeah.
One gets better, the other one catches up. And it just goes back and
that
forth,
would be
probably.
Interesting, because then really we wouldn't, if we really didn't know what was propaganda and what wasn't.
There might be only way would be able to tell is like with a robot, because it's so good that maybe only computers would be able to tell this weird
high
thing.
precision and stuff. Yeah.
You can still trick networks, kind of like. There's been problems with with
captchas and shit.
Yeah, exactly.
Right.
Right. Like you can still trick networks into seeing like images of like clearly something that any human would be able to tell is like completely just what the fuck is this, but when you input it into computer, it recognizes it as something completely different. Like for example, you could put in some junk noise that a human could look at as just like, what the fuck is that? And then the computer will say like, oh, that's a panda,
Right. I see a dog.
So so there's weird idiosyncrasies that the computer's going to have that a human would never have.
Yeah. It's like a Rorschach test for a computer, right? You just kind of see what you see.
Right.
You see what you want to see inside of it. Yeah, that's wild. Shit.
I wanted to see for you though, do you have any things that you would maybe Do you see any things that you would like to see applied, or you would like to see neural networking, machine learning, deep learning applied to?
Applied to?
Yeah, like, is there anything that you're just like, oh, I'd like to see this, apply. I'd like to see machine learning applied to X or Y or Z.
I would like machine learning to be applied to certain like aspects of research. I think it'd be cool to look at. I think somebody has already done this, but I think more fields should adopt it.
Yeah.
In looking at, because I mean, the science community generates hundreds and thousands of papers a year.
Yeah.
And probably only a fraction of them actually get read, And so there's a lot of science that we don't process because we filter it out because it's not. We typically, the funding goes, it typically follows the thing that's the hottest, most interesting, most novel thing happening right now. That gets the funding agencies to be like, oh, this is new and interesting. Let's fund that. So, but there are other things that kind of fall to the side and aren't picked up,
Mm-hmm.
So this would be something that I see as almost necessary to kind of push the boundary a little bit, because we need to really digest the kind of information we have.
So what are you saying, like to have more papers that maybe fall by the wayside rise to the top?
Or just get recognized, or maybe building like a sort of database of like how do you say it? Because not all of the search engines have everything.
Mm-hmm.
They just have a limited database. But if you could build like a database built on like a neural network of sorts where it scans like cross-sectionally across different databases or something, that would be really interesting.
But
like Google on steroids, but like, it's
yeah. I'm trying to figure out how you're saying how you would want to apply it though. Like, what's the end goal you're trying to get from it?
Try to get the most available information.
Okay, so you want the best papers, kind of.
I want all the information that's most relevant, because sometimes you don't have that with a lot of search engines.
I see, and not just based on like, well, I imagine they kind of do that with like citations, right?
Yeah.
Or do you think that's
not? Explain that.
So with citations, they just say, okay, whatever has the most citations gets placed on the most relevant.
Yeah.
And then you also have things of also time period.
Yeah.
If it's a closer year to where you're at, then it's more relevant.
Yeah.
So there's little things that don't really require machine learning algorithms that can easily just give you the best papers.
Filter out some things. Yeah.
So then you're saying that even that's not good enough?
But even that might not be good enough, because we might be pushing out some interesting things, is what I'm saying.
Because they're not cited very often.
Because they're not cited, because, they're not, or might be too old, or, it might not be interesting enough. But if there's an AI that can sort of sift through some things and compare, and I'm just thinking right now on the spot.
Let's kind of build it up right now. It's kind of interesting. So first thing I'm thinking of is like a crawler like Google has. So with Google, the crawler is, I don't want to say too much because I don't really know for sure. I haven't looked it up, but from my understanding, my rudimentary understanding of crawler is it looks through pages for keywords, and then it sees like how many keywords that page has, and if it has that word a lot, and then it links to a bunch of different pages related to it, it pushes those to the top of the search engine.
Okay.
So that gives it relevancy, essentially. So with what you're saying is you have like a crawler for a research paper for keywords, and then that pushes it to the top if it hits those keywords for whatever you're researching. But perhaps that isn't enough. So really would be ideal is like, let's say, I think what you're talking about is like, let's say you have some kind of experiment, and then there's some really obscure paper that does something similar that may be in a different field. Let's say you're looking for a physics experiment, but this one's in chemistry. And it's kind of similar, but they apply it to different something else.
Exactly, yeah.
So you could have a machine learning algorithm that can recognize that somehow, that there is a connection.
Yeah.
So I could definitely see what you mean. Like there could be a better way to have some kind of weird pattern between those two papers, let's say, that maybe a machine learning algorithm would recognize that a human may not.
Sure. And I think they already have, like sometimes the search results, have you ever done that when you run out of like let's say the first 2 items are really relevant.
Yeah.
And then the rest of the items
junk.
are like just guesses that the search function, it sometimes it even throws something at you and it says like what you were looking for. It says that like it's dashed out. It's actually not in this, but we decided to show it to you anyway. I wonder if that's happening at a lower level already, but I'm
you mean
not
with
sure.
machine learning stuff?
Yeah, I wonder if they're
I think it's
applying-
probably not. I think it's probably I think it's probably based on the kind of basic stuff, because it seems like what you're saying probably it could use some machine learning because, like you said, these papers, like what you want a lot of times, I've noticed with research papers, they're just so dense and heavy. It's like you get a couple good ones and then the rest is just completely like, what the hell even is this? So you need to find a way to sift that out quicker.
Yeah.
And to get all the relevant papers would be great.
Yeah.
But the machine learning algorithm would have to know what is actually relevant to you.
Yeah.
Because those papers have so much information. Like one paper could be relevant to you and someone else who has a completely different experiment because they're looking at some particular aspect of it that is relevant to them.
Yeah. Or they can give you, or the neural network can also give you a comparative kind of thing. Like it's comparative methods or, that kind of thing. Or it just a smarter search engine, I think would be kind of cool to see out of this tech.
Yeah. I could see that with machine learning for sure.
I would that would be really enjoyable, I think.
Someone would have to come up with a clever way to give it the parameters that it needs to make it better, though.
Which I can't think of what they would be yet.
Yeah, I mean, we're not.
Yeah, we're not machine learners.
We're not machine learners.
But some of these things are like they make sense to figure out, but this one might be a little bit harder.
Yeah, I mean, I'm sure Google can probably figure something out in 6 months if they have a whole team.
If they really wanted to.
They have a whole team of people. So get on that, people. Like no, I mean, and it would kind of make things like hunting. It's not necessarily just research, but hunting things down. Like you're trying to hunt down information.
Mm-hmm.
Google's not so great at it already.
Yeah,
I mean, it's okay, but
I hardly ever go back
past the first page on Google.
No, okay, you're right about that.
Damn, my camera really died.
Oh well.
Which one?
Someone. Yeah, I don't know why.
Yeah. I mean, I don't know, because I still think that I get some data. I still think it just sorts the data with the most hits a lot of the time.
But that seems to be the most relevant stuff. Because I never have to go to the second page of Google.
Okay.
Have you ever had to go to the second page of Google?
Sometimes. It depends on how...
It's very, like, if it's really obscure.
Here's the thing. You also have to know what to ask.
Yeah.
I think that's the most important thing.
And this is a trait in our generation that I think we have. We know what to ask.
Yeah.
But what if there's a search engine that knows what you mean when you type in what you say?
So maybe you can fill in your thoughts a little better.
Yeah, like connect dots that maybe, if I type, do like I feel stomach pains, what do I have or something?
Yeah. It'll probably still give you WebMD, which is probably the most useful.
I don't know. Just a smarter search engine would be cool. Maybe a smarter like experience in the browser. Maybe a smarter browser experience would be cool too.
Okay.
Or just build. I mean, the Google's already kind of doing this thing where it's building assistants as well, right?
What do you mean assistants?
Like it's building
like Alexa or whatever the hell that thing is.
There's Alexa. That's Amazon's version.
Okay.
Which is really poorly done in my opinion. And then Google's.
I don't trust any of that crap.
Google's assistant, which is a lot more seasoned. I think the tech on that is pretty tight and well done. But it still has a lot of holes. Like it's not, it doesn't execute things very well, but I think it's based off of machine learning.
Okay.
Cause you have hundreds of inputs of people interacting with this machine every day, but it still has to learn. Like sometimes I tell it to shut up and, like,
I don't see what would be the machine learning part of that though. Because really all it seems to me is just like voice recognition. And then it's just,
Google.
Because I think it sometimes needs to learn what I'm asking for sometimes. Sometimes it'll mess up.
That sounds like just voice recognition. But I guess maybe voice recognition has some machine learning components.
Yeah.
Because it's really gotten good now, and I don't know why it's so good. it might have some machine learning involved.
Yeah, I think it has to learn how to recognize your voice a little bit.
Okay.
Because it's always on, but it looks for a phrase.
Yeah.
So when it's always on, it hears you talking, and it's processing what you're saying, but it throws away everything and tries to look for a hot phrase.
I see.
So a key word. Mm-hmm. So when you say, "Okay, Google," it'll actually be like, "Oh, he said this." Boom.
Right.
Then I go into engage. And it's all really just at a fraction of a second that this all happens. It's really well done. I don't know how I imagine there's a lot of machine learning that went into it in processing people's words and knowing what people are saying. Because sometimes I'm sitting across the apartment and it'll turn on because it thinks it heard something. I didn't say anything remotely close to the hot word, but it's still engaged anyway. So I think it's still learning, but yeah, there's a lot of cool stuff that can happen with this tech, man. It's nice.
Yeah,
for sure.
But yeah.
Yeah.
Do you think animals? Do you think I can age my cat or something? Do you think I can age?
I don't know. You got to try.
Age my dog.
You got to try.
Animal filters.
No idea. I mean, I doubt it. I mean, maybe you could. I don't know. It depends on how crazy they got with the.
People love dogs, man. They'll fucking people will buy this shit. See how my dog looks when he's 15 years old or something. Let's get in on that. Right? Yeah.
But it depends on how deep they got with the image database.
Yeah.
I would imagine they probably just did people though, but I don't know.
Yeah, yeah.
Yeah, so let's see what else I had in here.
I'm trying to think like what other things you could do. I mean, you could bring back hologram what is it? Hologram Tupac. You could really use some machine learning to
and give him new movements and things.
Make him do new songs.
Well, here's one idea I had before I came over here of what you can do with the machine learning algorithm. I was thinking you can probably do something with food. So if you let's say this. There's a bunch of recipes out there, a shitload of recipes.
Make new dishes and shit?
Yeah, so the machine learning algorithm can come up with new dishes based on let's say it can look at French cuisine and then combine it with Filipino cuisine.
Because this is a great idea. Someone's gonna fucking take your idea, bro. Some fucking VC in California.
Give me 1%. You can have it.
I'll just take 1%.
We want to fund your idea. That's a great idea. New recipes that nobody's ever thought of.
Yeah, so I thought that'd be very easy because there's so many recipes out there.
Yeah.
You can just literally just kind of flip it around. The only thing is it has to do with some kind of intelligence, right?
Yeah.
So it would need to know that this is salty, so I can put something with sugar here and make a nice sugar salt combination. Or it needs to consider structure too. This dish may be runny, so it needs to be encapsulated in bread or something.
Right.
So the machine learning would have to have some kind of intelligence to it to combine these dishes.
Reasoning behind
it needs to understand the properties of the dish. Right. So you'd have to encode the properties as well as the recipes. Mm-hmm. But I think that'd be fairly doable. You just need to come up with some materials properties of your actual dish.
Yeah.
It's flaky, it's salty, it has, this X texture or whatever the texture is. And then once you do that, you can catalog all these dishes and then actually create new recipes from that.
Or you can say what flavors complement what.
Yeah,
flavors.
Exactly. So the learning algorithm can hopefully have something where it knows what flavors will complement. And then using those parameters, it can send it through each layer and then say, this is the dish it comes up with.
Or textures or things like that, what pairs well. And you could probably actually... You know what? I'm pretty sure somebody's already coming up with this because this is a huge moneymaker, but wine pairings.
With different meals.
Yeah, rich people love that shit.
Yeah.
So it's you can imagine that somebody's already thinking about doing this.
I'm sure. I'm sure if I thought of it, it's already being developed somehow.
Yeah, there's already some... I mean, the food thing is new, but I'm already going to say that there's probably somebody working on the wine one. And if not, then shit. Credit us,
Yeah, there you go. 1%.
1%. We just want 1%. That's
We're
a
cheap.
little bit.
1% ain't that much.
Come on. And I was thinking about this with food though. If there's something that can sort of guess your calories of your dish or something. Like you built a scale. You built a sense of scale.
They could probably already do that with just knowing, without deep learning though, because you could just know what your ingredients are and then just say the average of every single ingredient.
But let's say you're trying to minimize the amount of effort I have to do as a human being.
No, I'm saying, yeah, like let's say if you have or you mean like if it looks at an image of your dish?
Yeah.
Ooh,
You think you could ever get it to within an error bar of say 10%?
Maybe, because what you could do is like if it recognizes a dish, it could say, okay, this is an image. This is an image of pizza. Therefore, I know the average amount of calories for pizza is X.
Yeah.
So maybe then, but like if it's an unknown dish and it doesn't know what's inside, then I don't know.
But this is the most important thing, I think, building a sense of scale, right? You have to build a reference, right? So maybe if your camera, say you calibrate your camera, that's all you have to do. Do you think it's possible?
What do you mean calibrate your camera?
Calibrate your camera to a length. So you can at least just have.
No, I think it should just be able to tell by the camera phone, because the camera phone has built-in sensors. It has distance sensors.
Okay.
So if, let's say you have a donut on your plate, the camera should already know the scale because it literally has a sensor to know how far away it is from you.
Okay.
So it should be able to calculate that. You should do minimal work.
Okay.
Like there's already algorithms that do, like you've seen the Snapchat with the little hot dog dancing guy.
Yeah.
Like he scales depending on like where you put him at.
Oh, okay.
So they already know how to calculate distances just from the sensors within your phone.
Because I imagine that's another idea that can make a lot of money. Because like there's the people counting people watching their weight or counting their calories. You could just take a picture or something, and it'll say, "Oh, this is probably 1,000 calories."
Yeah, I could see that. That could say, this looks like a Dunkin' Donuts chocolate donut.
Yeah, exactly.
Therefore, we have the values for this guesstimated as X calories.
Yeah.
Yeah, I could see that.
You can
for
sell
sure.
that to Weight Watchers, bro. You can sell that to like some
all these food ideas now. Yeah. What we just need to do is just sit around one day and think of all the things that we can use machine learning on, and then just write all these ideas down and sell them to people, or put patents on them, patent troll.
Yeah. Just like wait.
Then you don't have to do any of the work. You could just say, "Oh, I had this idea."
Yeah.
One of my teachers, actually, back in my school, he was a patent troll, and he literally sued Twitter, I think. And I think he got a settlement for it. He sued Twitter because he said he came up with a system for social networking for celebrities. And he sued him, and I think he got a cut somehow.
Pretty lump sum, pretty penny off of it.
I was like, man, that fucker.
See, that's another way to make it in America, man. You just patent troll.
Sue people.
Yeah.
So.
Wow. Yeah, or you can make new Pokemon. If you want to do that.
I'm pretty sure that's already how they do it. Or they just put it in a hat.
Yeah,
pick
just
two animals.
All right, let's see what's going on here.
Not even animals, pick two objects.
Do you think AI could make, or machine learning could make a car? A new car?
Yeah,
build
like
something,
design
build something new.
different kind?
Yeah.
Sure.
Yeah.
There's so much potential for machine learning, man. I think it can do so much, so many things in the future. Like, you can literally just randomize values for anything pretty much, and it should be able to generate something. It's just a matter of picking your right parameters, not overfitting your data and all that. And actually, I should maybe explain overfitting. So overfitting is like one of these common things for machine learning stuff, neural networks too, where you put too much data in your system to where it creates a perfect fit for your data. But then let's say if you get new data in, you have a high amount of error because it fit it perfectly to the data that you had as it was. But then when you added in new information, it was so well fit to that data that it didn't extrapolate it properly. So now it doesn't work right for your fit. So you should have like a balance. Like your data needs to be fit in such a way where when you add new data, the error is minimized. So consistently minimized. Because when you fit it too well, then once you add new data to it, the error gets huge.
Yeah,
and maybe I can
you're saying something farther from the, like say the line is what's normal.
Yeah, let's say you have a scatter plot, right?
Yeah.
So let's just imagine data visualized on an actual graph. You have a bunch of points on a graph
and
in a linear,
and all the points are say images of something.
No.
Images of a hamster.
No. Why you gotta troll one?
Okay. And you're throwing a cat.
God damn it.
Just kidding. Okay.
So the points are just points, right? They're in a linear. They look like they're in a linear fashion.
Yeah.
So like a line just moving up like a slope of a line. And you want to fit a linear line to that.
Yeah.
But if you overfit it, it will fit it like a polynomial. Every single point will be fit on that line, and it will be like a squiggly line.
Sure. Yeah.
I'll even put an image of that from Wikipedia. It's a really nice image, simple image. And if it overfits, you know, if it's a curve to every single point, that's stupid. But then when you add a new point, your error is huge because it doesn't know what that function is now. It doesn't match that function.
Yeah.
But if you have just the linear line fit, then when you add a single point in there, you have a very tiny error because it's still consistent.
Yeah.
So that's what it means to overfit your data. So you have to be careful with overfitting with neural networks a lot of times.
Nice.
So
yeah. So with that, I guess I don't know if does that
satisfy?
I'm wondering if it's where else we can go with neural networks.
I think we're pretty good. We're at 59 minutes. So.
Oh shit! There we go.
Yeah.
Damn. What a perfect time. Yeah. Speaking of.
Planned.
Is that one it?
Perfect.
Yeah, there you go. Yeah, man. Well, this was fun.
Yeah.
You know, we still haven't given the people what they wanted.
What's that?
Quantum information.
Oh. Yeah, we'll do that soon. We're gonna actually upload. Yeah,
we're still
we're
debating.
gonna do that soon.
We're still debating with each other of whether or not, because we don't want to fuck this topic up. Okay, we really want to do it justice.
Yeah. So quantum information, we're gonna do some studying and figuring out, and it'll be coming soon.
Yeah, it'll be coming soon. We do have, actually, I'm not sure what order we're gonna decide to drop them in.
Just like, whenever they get recorded, it's gonna be in sequence.
Okay. All right. Gotcha.
Yeah.
Yeah. But look forward to that.
Yeah.
Shout out to Eric Weinstein or Weinstein. Weinstein.
Yeah.
Is that how you pronounce it?
Yeah, Weinstein.
Okay, there you go. Yeah.
German.
So, there you go.
So yeah. All right.
Anyways, with that, peace.
Signing off.
Yeah. Yo, thank you for sticking around this long.
Thanks for watching, guys.
Yeah.
So basically, just make sure.
Yeah.
Make sure to subscribe to our channel. So remember, like, comment, and also to follow us on Twitter. That's going to be at Eigenbros. And the audio podcast is available on Spotify, Apple, and Google Play, and all those nice platforms. So we'll see you later, guys.
All right.
Appreciate it.
Yeah.